Hello, class. This is Mr. Harmless, and I'm working on problem number 10. This is from Unit 2, homework number 2. And we're going to solve for x and y in this question, okay? So first of all, we know that these lines are parallel, so I'm going to put my little parallel symbols here. And then we're going to look for some angles that we know something about. So for example, I'm going to pick out this angle right here and this angle right here. These two angles right here and here, these are consecutive interior angles, okay? Consecutive interior angles. Consecutive interior angles because they're on the same side of the transversal and they're between the two parallel lines. Consecutive interior angles, if the lines are parallel, are supplementary. And that's only if the lines are parallel. So that means I can take 6x minus 7, and I can take this 3x minus 29. And I know that together, in other words, adding them, they will equal 180. Now, this is how I'm going to be able to find, or how I'm going to be able to solve for x. Notice in this equation that I came up with, based on what I know about geometry, the x's are both in here, and that's all I have. I don't have the y. It's not in here at all. So this is going to make a great equation to solve for x, which I'll do in just a second. But first of all, I want to go back to this problem. I'm going to switch over here to orange real quick for just a second. Notice I don't have a connection between this angle and this one. There's no special name, but I do have a connection between these two. This angle and this angle are vertical angles. Vertical angles are congruent. And that's all the time, whether or not the lines are parallel. In fact, it doesn't really matter because we're not looking at the parallel lines at all. We're looking at just these two lines right here. Vertical angles are congruent. So I know that this is also true. I know that the 8y plus 17 is equal to the 6x minus 7. So notice this equation is true. I wouldn't be able to start with this one because I have an x and a y in it. But if I do solve this problem first, I will be able to take my x that I find and plug it in right here so that I can solve for y. So let's go ahead and do that real quick. I'm going to switch over to red ink here. And let's combine our like terms. The 6x and the 3x makes 9x. The negative 7 and negative 29, 36, is that right? Minus 36. I don't have anybody here to check me. 180. Add 36 to both sides. Okay. So we get 9x equals, 6, 8, that'd be 11, 216. Hopefully I did that right. Divide by 9, and we get x equals, and I'm going to use my calculator, 216 divided by 9, 24. Okay, so there's my x. And now I can take this x, and we're going to take it up here, right? And we're going to plug it in right there where that x is at. So now we have 8y plus 17 equals 6 times 24 minus 7. And I'm going to use my calculator again because I don't want to think about this in my head. So it's 24 times 6, 144, minus 7. 144 minus 7. Oh, gee. Minus 7. Well, math teachers shouldn't need their calculator this much. 8y plus 17 equals 137. Subtract 17. I'll do this one in my head. Subtract 17. I'm running out of room here. Let's skip down to this way. 8y equals 137 minus 17 is going to be 120. And divide by 8. And so y equals 120 divided by 8. And we get 15. So there's my x and my y for a problem like this. And the key to doing these problems is that you're just setting up these equations based on what you know. Well, I missed that. Based on what you know about these, about the diagram and what's true. And then you'll come up with some form of an equation that you can solve. One of them will have just one variable that you can solve first, and then you can find the other one. Okay, if you have any questions, please rewind this, watch it again if you need to, and make fun of my math skills, and then ask me questions if you get stuck. Okay.